Hello everyone, welcome to my channel AURORABYTE. Today we will start our first chapter, that is GOC, General Organic Chemistry. General Organic Chemistry. So in organic chemistry, there are two basic tools that one of these is GOC and other is stereochemistry. So GOC is one of the basic tool of organic chemistry. Here we will discuss about some effects. Firstly, primary effect. Secondly, secondary effect. In primary effect, we will discuss about electronegativity and size of element. In periodic table, if we go left to right, size decreases and electronegativity increases. Whereas if we go top to bottom, then the size increases due to increasing of atomic number and electronegativity decreases. We can explain this via acidity. So what is acid? Acid is the species which release the H plus ion. If H is an acid, then it dissociates into H plus and the remaining A minus is called the conjugate base. So acidity is dependent on the concentration of H plus. We can write acidity is proportional to concentration of H plus. It is also inversely proportional to pH. We know the pH is scaled from 1 to 4. The pH is 7. Below this, we say this acid and above these are base. It also proportional to Ka, which is dissociation constant. And inversely proportional to pKa. pKa is basically minus log of Ka. So let us an example of some acids: HF, HCl, HBr, HI. These four acids. If we consider the acidity order of these four acids, so they are dissociated H plus and F minus, for HCl H plus and Cl minus. For HBr it's H plus and Br minus, and for HI it's H plus and I minus. If we want to compare these four acids, so we have to consider these conjugate bases and compare the stability of these conjugated bases. Actually, the acidity is also proportional to the stability of anion. This anion is basically the conjugate base. Now, if we want to compare their stability of these anions, we have to compare the size first. The order of size is I minus, it has large size, then Br minus, then Cl minus, and then F minus. Now this iodine, which have the large size, due to its large size, the negative charge on the iodine is more dispersed. The negative charge is more dispersed. That's why the charge density on this atom is less. Negative charge density, that means it's then more stable. So from the size order, we get the stability. The stability order is also the same. I minus, then L minus, then Cl minus, and then is from the stability order of this anion, we get the acidity order. Corresponding the order is HI, more acidic, then HBr, then HCl, and then HF. Here are the primary effects, and then the secondary effect. Secondary. In secondary effect, we will discuss about basically four effects. One is inductive effect. Next is hyperconjugation. Next, resonance. And isometric. Here are the four effects we have to discuss. Today I will discuss the inductive. Inductive what effect basically generates due to the electronegativity difference. It generates electronegativity difference. The SPCl bond. This chlorine has more electronegativity than the carbon, so that it pulls the bonded electrons toward it. Oppositely, we can say the carbon atom is more electropositive than chlorine, so that it pushes the bonded electron. So the carbon atom pushes the bonded electrons toward chlorine. This effect is actually called the inductive effect. Now, the inductive effect operates via sigma bond. Then it is a distance dependent parameter. Distance dependent parameter. Independent effect. We can say. Now this inductive effect is of two types, plus I and minus I. In plaza effect, basically the electron donating groups shows the plaza effect. All anions shows plaza effect, and less electronegative neutral groups show the plaza effect. For example, C3, C2H5, And for minus I effect, electron withdrawing groups and all cations which have positive charge and more electronegative neutral groups. So, for example, C double bond unsaturated bond is present, then C triple bond in, etc. Now, let us consider some examples. Example CF3 and CF. We have to consider the minus I. What is the minus I order? It's very simple. In CF3, you see the carbon atom is attached to 3 fluorine atoms, and for CF, the carbon atom is attached to 1 fluorine atom. The fluorine atom has higher electronegativity. It pulls the bonded electrons from carbon. So here, the total group is more electron withdrawing. More electron withdrawing group. And for this, only one fluorine atom is attached to the carbon. It's less electron withdrawing. So the minus I order is CF3 greater than PF. Now, let us consider the second example, which is OCOCH3, and what is the minus I order here? Here we can see the oxygen atom here is a lone pair that involves in conjugation with the carbonyl group. This conjugation, this group is more electron withdrawing. The minus I order is, if we consider this is A and this is B, A is greater than B. Now the third example, CH3, H2, CH3, and CH, CH3, CH. Yeah, what is the plus I order? Very simple problem. Here we can see the C3 group. Here, additionally, one C3 group is there. So it's more electron donating nature than this. And here, two C3 group is there. This is more. Electron group. So the plus I order A, B, C, greater than B, greater than A. Now, what are the applications of this inductive effect? Effect playing the stability of carbocation Second application is this effect also explains the acid and capability. Consider another examples of these applications. Acidic 3-degree carbocation, green 2-degree carbocation. If we take all carbocations, we can see from right to left, the stability increases. We know the 3-degree carbocations are more stable than 2-degree than 1-degree. And here the plaza effect is also increased. 3-methyl groups are attached with this carbon, so the plaza effect is more stability carbon proportional to transparency. Similarly, for free radical, this property is exactly the same. Second example is for carbonate. We consider 2-degree, 1-degree. Stability of carboanion increases, but the plaza effect is decreases. So we can write that the stability of car- for example. And to compare the acidity of these two acids, make the conjugate after releasing the image class, we get the conjugate. Now we have to compare simply the stability of these two conjugate bases. Which conjugate base is more stable, the corresponding acid is more acid. From here we can see the chlorine atom electron withdrawing group that withdraws this negative charge on the oxygen atom, and the R. So here the minus charge of on the oxygen atom is dispersed via the electron withdrawing group, that is chlorine. So this is more stable. And charge here, the R group increases the charge density actually on the oxygen atom listed. So the acidity order is A and this is B. Acidity order is A greater than. This is the more acidic, more acid. So this is all about the inductive effect and we will dive discussion for today's class. Yeah, here are some exceptions also. I will upload them in the shorts. Please keep following that video. And if you like this video, then press the like button. If you have any doubts, so write in the comment section. And if you are new in my channel, so please subscribe. Thank you for watching. See you in the next video.